Okay, in class today I put a pin in a couple of the problems and said I would come back to them in a video, and these are the videos that I promised. The first one was in the what do you call it, the series problems. And it was about number 6, okay? And the series there is the sum from n equals 1 to infinity of the natural log of n over n plus 1. So the key to this problem is kind of working out what are the partial sums. So the first partial sum would be just this, the natural log when I have 1 over 1 plus 1 is 2. So that'd be the natural log of 1/2. The second partial sum is going to be the first partial sum, the natural log of 1/2, plus, okay, so then we're going to add a 2 for these. So it's going to be 2 over 2 plus 1. So that's 2, not that. We got to remember the natural log of 2/3. All right, so that reduces, using the laws of logarithms, the natural log of 1/2 times 2/3, which is the natural log of 1/3, okay? So S3, well, that should be this sum, because this is S1 plus S2. So this is S1 plus S2 is the natural log of 1/3, plus now A3, so it's A1 plus A2, sorry, gets me S2, right? A1 plus A2 gets me S2, which is this. A3 should be the natural log of, well, that's going to be 3 over 4. And by the same logic as above, I'm going to get the natural log of 1/3 times 3/4, which gives me the natural log of 1/4. All right, so we see a pattern here. The natural S1 is natural log of 1/2. S2 is natural log of 1/3. S3 is a natural log of 4. So the kth partial sum should be the natural log of 1 over k plus 1. All right, so when this is greater than 0, which as this thing's going to infinity, it's going to be greater than 0, the natural log is continuous. So the limit as k approaches infinity of the natural log of 1 over k plus 1 should be the same as the limit as k approaches infinity. Oh, excuse me. Okay, the continuity allows me to bring the natural log into the inside here, right? So it's the natural log of the limit as k approaches infinity of 1 over k plus 1, which is, well, I'm starting to now approach, this is going to approach near where the natural log starts going close to 0, right? So if I look at the natural log function, it does this. It has an asymptote at 0, right? So this is what the natural log of x looks like, right? So as I'm getting close to 0, as this thing starts getting close to 0, that thing goes down to negative infinity, which means that the partial sum, the limit of the partial sums, does not go to a finite value, which means that this diverges. Okay, so I only get this converging if this goes to some finite value, right? But because it does not, it goes toward negative infinity. This diverges. All right, so there's a little bit of look at that one. And I also promised one other problem here, right? So I'm going to drop that down. And the other one was on the harmonic and geometric series, right? And this was problem number 1. All right, so it wants to know what is the sum from I equals n to infinity of 1/3 to the I. Okay, so kind of looking at that, the key here is recognizing that if I have I equals 1 to infinity of a times r to the I minus 1, when the absolute value of r, so given the absolute value of r is less than 1, this goes to a over 1 minus r. So I need something that looks like this. Okay, so the first thing I need is I need this bound to start at 1. So I'm going to move this around so that I starts at 1 and goes off to infinity. So I'm still multiplying by thirds, right? But I'm going to start at n, and then I'm going to add the I and subtract 1. So if I think about this, if I put like 1 in here, I get 1 minus 1 is 0, so that's just n. If I put 2, I get n plus 1. 3, n plus 2. So that's going to work because this starts as n plus 1, n plus 2. It's the same thing. So rewriting that got me this. Now, I know that if I have like a to the m plus n, that's a to the m times a to the n. So this should be able to be rewritten as I equals 1 to infinity, 1/3 to the n times 1/3 to the I minus 1. Now that n is not part of the counter, it's a constant, right? So this is a constant value. That's the a in my equation here. This is the r, and the absolute value of 1/3 is definitely less than 1. So this is going to equal 1/3 to the n over 1 minus 1/3. Well, 1 minus 1/3 is, of course, 2/3. And division is the same as multiplication by the reciprocal. So this is going to give me 3/2 times 1/3 to the n, which I believe is answer C in the problem. All right, so those are the two that I owe you. Said that I would look at and put a pin in. So hopefully this helps. So there you go.